Hello, this is me again, Angelica, and I will be demonstrating two different codes with which will investigate the safety of enumeration types by the use of the C++ and a C sharp. So let's begin by examining the C++ program. So with our basic, common heading. So this will include our input and output stream library. And we also use a standard namespace, which will allow us to use count without the std prefix. Okay. So now we will talk about the enumeration declarations. I declared here two enumerations. The day enum starts at 1 for Monday and subsequent values auto increment means 2 for Tuesday, 3 for Wednesday, 4 for Thursday, 5 for Friday, 6 for Saturday, and 6 for Sunday. And for color enum, we don't assign value, so it just starts 0 by default. So these two separate enums will help us test type safety. Okay, so in our activity, we will um, check or investigate the different operation. So in my operation number one, which is direct assignment, this is safe. So this is correct and safe way to use enums. I assign an enum value directly to a variable of the same enum type, and this prints the numeric value 1 because Monday is 1. And that's it. This operation is safe. Then for our second operation is arithmetic on enums. This is unsafe but legal. So in C++, it allows the arithmetic on enums with explicit testing. So this is unsafe because because we could calculate outside values. I mean, we could calculate values outside the valid range. So here, today plus 1 equals 2, which corresponds to Tuesday. So again, this is unsafe but legal. For operation 3, which is direct integer assignment, this is purely illegal. And this line is commented because C++ does not allow direct assignment of integers to enums without casting. And this would cause a compilation error showing some type safety. And for operation 4, we have cast integer to enum. This is unsafe but illegal. And why? Because with explicit casting of C++, it allows any integer to be converted to an enum, even invalid values like 99, right? So this is dangerous because there is no boundary checking and the program will print 99. Okay? So again, this is unsafe but legal. For our operation 5, we have it a cross type comparison. This is also illegal because C++ prevents comparing enums of different types without casting. And this is commented again because it would cause a compilation error demonstrating type safety between different enum types. And then we have operation 6, which is same type comparison. This is purely safe and comparing enums of the same type is perfectly safe and legal. So this returns true one because today is Monday. So today is equal to Monday. So this is true. then it will returns true. And then for operation 7, which is again in operation 6, it is true because we are using boolean. Okay, let's continue. Operation 7, we have switch statements. This is safe. Switch statements are the intended use case for enums, and this is safe and readable. Since today is Monday, it prints it's Monday. Okay, so next we have again, this is safe. We have operation 8, increment with cast. This is unsafe but legal. C++ doesn't support the increment operator directly on enums, but we can cast it. So this changes today from 1 to 2, which is Tuesday. And it is unsafe because we could increment beyond valid values. So maybe we could, our declaration is until 7 for Sunday. So this is unsafe because we could increment beyond valid values. But this is safe. This is unsafe but legal. Next, for our operation 9, this is out of range value. This is unsafe again, but legal because C++ has no runtime checking for enum ranges, and we can assign 1000, which is completely invalid for our day enum. And this demonstrates poor type safety. Why? Because again, this is unsafe but legal. Unsafe because again, the C++ has no runtime checking for enum ranges. So for our declaration, it's just until 7. And here, we call it out to until 1000, sign 1000, which is completely invalid for our declaration. So again, this is unsafe but legal. Now let's move on to operation 10, which is negative value. Negative value is unsafe but legal again. So similarly, negative values are allowed with casting, even though they make no sense for days for the week, and the program will just print -5. Then we have operation 11, which is multiplication. This is again unsafe but legal because C++ implicitly converts enums to integers in arithmetic operations. So today is 2, which is Tuesday. So 2 times 2 equals 4. So that is legal but unsafe. For our operation 12, we have cross type assignment, which is unsafe but legal. But be um always remember that it could be legal if we have cast. So with casting, we can assign one enum type to another. So this is nonsensical. So converting a day to a color, but the C++ allows it to days to which corresponds to blue in the color enum. If you could still remember blue, why blue? If we are calling in here, we are calling 2 for Tuesday. So here 1 is Monday, 2 is Tuesday, and red is by default because we didn't declare value here as 1. So 0, 1, and 2. So that is Tuesday and blue. So let's move on to our C sharp. So in our C sharp, this is similar to C++. We import a system which will define a program class and declare the same to enumerations. We have enum day and enum color. And then in C++, we have it here day tomorrow equals day into day plus 1. In C++, we must explicitly cast the enum to int before arithmetic. And here, then this requires double casting, which will makes the code more verbose but also more explicit about type conversions. So, if you could see in operation 1, just like on our C++ that is safe, then we will move on to operation. Then let's continue on operation 4. Like the C++, C sharp allows casting any integer to an enum without validation. So this is equally unsafe. So same operation with the C++. Then we have it here. We noticed on operation 11, like the C sharp allows casting we explicitly cast the enum to integer before multiplication, unlike the C++, which does this implicitly. So in output differences, the C sharp displays enum names when printing. So operation 1 shows Monday instead of 1 for invalid values like 99. And in C sharp, it prints the numeric value since it can't map to a name. Just that for output differences in our 12 operations. So for the output of our program in C++, if we will run this one. So we have it here. Operation 1 to 12. Operation 1 directly assignment today equals 1. For operation 2, arithmetic today plus 1 tomorrow equals 2. Then we have it here for our C sharp also. If we will run this one. So if you could see in C++, it gives you 1, but in C sharp, it gives you Monday, just what I told you a while ago, that the C sharp will print numeric value since it can't map to a name. So for comparison, both languages show similar unsafe behaviors. The main differences are in C sharp, displays enum names when possible, while the C++ shows numeric values, right? And what we have observed is that the C sharp requires explicit casting to int before arithmetic operations. And also in C sharp, it shows true or false for booleans, while in C++ it shows 1 and 0. And what else? Both C++ and C sharp allow dangerous operations like out of range values and cross type assignments with casting. So both programs demonstrate that C++ and C sharp enumerations have similar safety issues. We could see it in our output. So what's safe is are direct assignment for enum values, comparing enums of the same type, and using enums in switch statements. And what's legal but unsafe are operations, casting any integer to an enum, even invalid values, performing arithmetic on enums, assigning values outside the defined range, converting between different enum types, and no runtime boundary checking. And for what's illegal are those we had commented our code here to two operations, the direct integer to enum assignment without casting and comparing different enum types without casting. So to conclude these two different programming language, so both languages prioritize flexibility over safety with enumerations. While they prevent some obvious mistakes at compile time, they allow many dangerous operations through explicit casting. In here, in our C sharp, this is slightly more explicit by requiring double casting for arithmetic and what else? Making potentially unsafe operations more visible. However, neither language provides runtime validation of enum values, which can lead to logic errors that are difficult to debug. So, for me, for safer code, maybe we should avoid arithmetic on enums and validate enum values when receiving them from external sources, and then never cast arbitrary integers to enums. And maybe we will use enums methods like enum is defined in, especially here in C sharp for validation. So thank you. And this concludes my demonstration in C sharp and C sharp and the C++ about enumerations. Thank you.